All right, we'll go ahead and get started. Our next speaker for the afternoon is Jorge Vega from UNAM, and his talk will be on the hyperspace of non-cut subcontinua.
Okay, thank you. Hi, everyone. I would like to thank the organizer for the invitation. And this talk is part of my PhD dissertation. The Professor Verónica Martínez de la Vega is my advisor, and the Professor Jorge M. Martínez Montejano is part of my tutor committee. And let's start. Let me remind the definition of a continuum. It's a compact connected metric space with more than one point. Given a continuum X, we define the hyperspace Cx, the collection of all subcontinua of X, and for a subcontinua of X, we say I is a no-cut set if the complement of A is connected, and define the hyperspace NC star X, the collection of all of no-cut set of X. The hyperspace NC star X was introduced by G. Boboc, P. Piri, and G. Vernon, and R. Escobedo, C. Estrada Obregón, y J. Sánchez Martínez. The hyperspace Cx is considered with the Hathorne metric H, and NC star X is endowed with the topology as a space of CDX. Now, let me remind the definition of a continuum we work. A dendrite is a locally connected continuum which contains no simple closed curve. For example, this fan is omega, and it's 0. A finite graph is a continuum X that can be set a finite union of R should that H of 2 of 10 intersect a finite set. For example, the news, the figure 8, and the theta curve. A tree is a finite graph which contains no simple closed curve, like this. The first result gives you a characterization of the subcontinua of CDX are a no-cut set, and the condition if only if A equal to X, A equal a singleton of endpoint, and A is equal to the complement of the component of a complement in a point, with the point is different at endpoint. The first consequence of this theorem is this proposition: if X is an interval, then NC star X is homomorphic to X. The idea is so simple: beginning 0, consider like all kind of continua like this, and the total X, and beginning 1, consider all of continua like this, and the total X, and we have the all of no-cut set of X are homomorphic to the interval. In the next result, we study the structure of NC star X in a tree different from the interval. And we have NC star X is homomorphic to the sum topology of this key out at this collection of semi-open arcs I and this collection of semi-open arcs J. A corollary of this result is the number of the components on this hyperspace, given by this formula, and depends on the number of the branch point and the end points. Let me give you an idea from the construction, a model of NC star X when X is a tree. Let's start. So this is a classic form to see the Cx hyperspace of a continuum. And let be a external edge like this. External edge is a edge with endpoints. And begin in this continuum. In this continuum, and consider all of kind of this continuum like this and the total edge. These continua are represented in the hyperspace with this arc beginning X. Similarly, begin in the endpoint. Consider all of these continua like this, except the total edge, because the complement is not connected. And these continua are represented by the semi-open arc beginning at 1, X. If you take another external edge, we have another two arcs, arc beginning X and another semi-open arc beginning at 1X in different endpoints. So if you take all of external edge, we obtain a queue with center X and this collection of semi-open arcs. So if you have, and let an internal edge, consider all of these continua like this, again, except this one, because the complement is not connected. And this kind of continua is represented by this semi-open arc. Analogously, if you take the kind of continua like this, is again represented by this semi-open arc. And again, if you take all of internal edge, are represented by this collection of semi-open arcs J. And that's all for the construction of NC star X when X is a 3. The next result gives you a condition, the LXB at 3, NC star X is a continuum if only if X is the interval. And the next problem is possible NC star X is unique? The answer is no, because there are nomomorphic trees in the family of the trees. Nomomorphic should that NC star X is equal to NC star Y. If you have in mind the model or repeat the construction of the model of the tree in X and Y, we obtain the models are the same. In this section, let me show you more some examples of the models of this NC star X in a classical graph. The first graph is the news. This figure is the model. And let me basic idea for the model is similar to the arc, beginning the singleton of P, growing to L, and growing to X, like this. And take a point in S, consider all of no-cut subcontinua of X, except the continuous containing this point B, is the representative of these two cells, this figure, and growing to X. In this case, in this example, NC star X is connected and not compact. Furthermore, this model is embeddable in R2 and the dimension is 2. The next example is the candy. Not this component is similar to the previous example, and let me explain the two cells. This cell represents the subcontinua R in this arc. Stay in this arc, and this cell represents all of no-cut set in this arc. In this example, NC star X is not connected and not compact, and again, the model is embeddable in R2 and the dimension is 2. With these ideas, we have the following models for the dumbbell and the figure 8. In both cases, NC star X is connected and compact, and again, the model is embeddable in R2 and the dimension is 2. The next example is a little general. Is the caterpillar. With the idea for the previously examples, this is the hyperspace, the model of the hyperspace. In this case, NC star X is connected and not compact. The model is again embeddable in R2 and its dimension is 2. And the number of the components is given by that number, where n is the number of the cycles in X. With these ideas, we have the model of the train. This is the train. And this is the figure of the model. And again, it's not connected, not compact. the model is embedded in R2 and have the same number of components. This example is interesting because NC star is connected, but we can model this hyperspace. The reason is we have a 4 odd in the space, and this implies we have a 4 cell in the hyperspace. Next, the final example, it's a lot of examples, is the theta curve, like this, and the model of the theta curve is the following figure. In this case, NS star is connected, no compact, and the difference is this model is embedded in R3, and the dimension is 3. With these models, we have 2 questions. The first is it possible to characterize the connectedness of NC star X when it's a finished graph in relation to the cycle of the graph? Because we found graph with n cycles not connected and graph with n cycles connected. And the next question, is it possible to classify the graph whose hyperspace can be embedded in R2? Because again, have graphics in R2 and graphics in R3. The next result is related to the compactness. And LXB affinity graph, then NC star X is compact if only X is homeomorphic to the interval or homeomorphic at the circumference. A corollary for this theorem, LXB affinity graph, then NC star X is homeomorphic to X if only if X is an interval, and NC star X is equal to Cx if only if X is a simple closed curve. A little generalization for 2 is the next result. LXB a locally connected continuum, then NC star X is equal to Cx if only if X is homeomorphic a closed curve. Another result in the class of the affinity graph, if X affinity graph, then NC star X is locally connected. And let me introduce another family of graphs. Let's say the affinity graph, we say this is a pi, there is a tree and circumference, so that both X is the union of both, and the intersection are the endpoints of the tree, like this figure. With this family, we have the 2 results. NC star X is connected, and using the fact NC star X is locally connected, we can prove this hyperspace is non-incoherent in this family. The next problem is a question: is possible if X is locally connected, NC star X is locally connected? The answer is no. This is the counterexample. And the counterexample say, if X is a Riemann dendroid, then NC star X is not locally connected. The idea from this example, if you have in mind the model of the trees, in this dendroid, we have a sequence of semi-open arcs to converge an endpoint, and this sequence broken the locally connected property. For last result, we have a little generalization in a family of dendroids, and the result is LXB a dendroid that satisfies the set of branch points of X is dense, then the hyperspace NC star X is a totally disconnected space. Example of this family of dendroids are the universal dendroid. It's a figure of the 4, and that's all for my talk. The reference for the previous work in NCX, and that's all for my talk. And thank you for listening and for staying here.
All right. Any questions for the speaker?
may I say a comment on this? It was very interesting, and I would like to add some results I got with Ala Samulevich 4 years ago. We studied separating sets or continua. So in your terms, it is called non-cut or cut continua, right? Okay, so we studied for manifolds or some spaces similar to manifolds in dimension 3 or higher. So then we got the characterization that this hyperspace is homomorphic to the infinite product of open intervals. The method is totally different, and the behavior of these hyperspaces in low dimension is different, as you show. So this kind of strange situation.
Okay. Is possible to send me a copy for the work or a link for the report?
Yeah, okay. I will send you.
My email.
Yes, I put it in chat. I give you this in chat. Okay.
Thank you so much. I stop sharing. Sorry.
All right. Any other questions?
Very nice pictures. I just wanted to say that.
Thank you.
All right. Let's thank our speaker again.
Thank you so much.
Our next talk will begin in about 13 minutes.